we're kind of down into the final days. Now, all of you, I assume, got the message that there will be no class Monday. I also extended your exam 5, I believe, through Monday. Although hopefully most of you will finish it as soon as you do your ALEKS homework while it's still fresh. Okay. Well, these are problems that I have extracted that are very similar to ones that have been on previous tests. Okay. This is not a previous test, but these problems are look-alike. Kind of like I've given you in the citation for these. So let's go through these. Simplify log 3 of 8. Okay, let me see if I can enlarge that slightly. Going on the rail there. Okay, simplify log 3 of 8. Okay, what they want you to tell what this is equal to, or what y would be, even though it's not shown. Okay, now I told you this to what power equals that is your thinking basis. Well, 3 to the first is 3, to the second is 9, to the third is 27, to the fourth is 81. So by that criteria, it equals 4. Now, otherwise, you can convert this to exponential. 3 to the y equals 81. Well, 3 to the y equals 3 to the fourth, so y equals 4 when you pull out those. So that's 2 different ways of working this problem. Okay. Problem number 2. Thou shalt not have a radical in the denominator. Okay. Now this one doesn't have any minuses or pluses, so we don't have to do the conjugate thing. That's only when you got minuses or pluses. But what we need to do is break down each one of these and see if we can extract any stuff. Or the other way, we can put them all over one radical or under one radical. Okay, now, given this, four goes into 125 times. X goes into X once, and X goes into this, making it to the fourth power. Because this one removes one of those powers. Okay, we're gonna, in this case, this is the smaller one, so that becomes a 1, and this becomes a y to the second. So after I've done all of that, I now have 25 x to the fourth over y to the second. I can extract that, and it gives me 5. I can extract this, and it gives me x squared. I can extract this, and it gives me y. So this is my answer. Okay. My suggestion to all of you is to write these down. Can I go on? Give myself a little more room this time. You probably ought to put your computer away and just copy this stuff down tonight. Okay, here, these two happen to be conjugates. Oh, no, they're not. They're not. Because we got different front terms, we got different back terms. Duh. I was just looking at the plus and minus. Got to look at the whole package. So what we're going to do then is we're going to take this times that, this times that, this one times that, and this one times that. So 3 times 2 is 6. 3 times 5i is 15i. Now, negative 2i times 2 is negative 4i. They're the same kind of units, so I can line them up. And negative 2i times 5i gives me negative 10i squared. Now, if you remember, a whole bunch of you left off that square on your unit 2 or 3 or whatever test it was. Okay? Now, we can add this stuff up. 6, those two give me 11 plus 11i, and this gives me 10 times negative 1, because I squared is equal to negative 1. 6 plus 11i plus 10. Negative times negative is positive. 6 and 10 are 16 plus 11i, and it must be in that order, a plus bi. Okay. What was your question?
I said, I don't know why I thought you kept the I squared.
No, you always, there's the rule I square equals negative 1. Okay, this one, I need to make sure that I didn't chop something on this one. Nope. My common denominator is x plus 4, x minus 3. Okay. Now, this is not an equals. So we have to do the missing parts method on common denominators. Okay. This one is missing that part. This one is missing this part of the common denominator. So we take that 5, brings this one's missing part. Basically, I'm taking it times numerator and denominator here. Okay. Minus 2 times this missing part. Like so. So now I have 5 times x minus 3 minus 2 times x plus 4 all over x plus 4, x minus 3. Okay, common denominator arises. What do you suppose I need to do next? Well, I need to distribute this here and here, and that there and there. Okay, so that gives me 5x minus 15 minus 2x minus 8. Watch out, don't drop that. Don't drop that minus. And it's real easy to do. Over x plus 4, x minus 3. Okay, so back to where we were going. Let's combine like terms. 5x minus 2x is 3x. Okay, so I've taken care of those two. Negative 15 and negative 8 makes negative 23. So I've taken care of those two. All over x plus 4, x minus 3. Questions? Don't need to. Actually, you don't want to. One thing you might have to check though is to see if anything up here could factor so you could cancel one of these. Okay, in this one you can't. But you do need to check this numerator and make sure that it won't factor into something that'll cancel down here. And if it doesn't cancel something down here, there's no point. Okay. Okay, factor cancel where we can, right? Okay, well, first of all, I see a 2 of them come out of everything up here. Which leaves me x squared plus x minus 2. Nothing will come out of that one. So I just have to see if I can factor it. 3 and 1, 2 and 1, or 1 and 2. The signs say that I'm going to subtract, right? I'm dealing with the denominator here. Okay. This way I get a 2, this way I get a 3. If I subtract them, I get a 1, which works. Sign-wise, this 1 has to be positive. So the biggest one is positive. So there, and then this one comes around here. There's the negative, and we put in the x's. So this thing factors into 3x minus 2 and x plus 1. We need to see if we can factor this numerator. Two times x plus 2 times x minus 1. That's what this factors into. 2 times 1 is negative 2, okay? And for the middle term, I'm going to subtract 1, or 2 minus 1 is 1, and it's positive. Okay? So I've got that over this. Now, as it turns out, nothing will cancel. Could have left it just like this. But You don't know until you check it. Okay? Say again? Yes, better be safe than sorry. Most of the time you'll be sorry if you don't. Okay? Say again. I would take either answer, this one or that one. But to be on the safe side, you better try this. Okay, you ready to go on? Multiply, we can put them under one radical or we can deal with them separately. But either way, we got a pair of eyes we got to extract. Okay, this becomes that. So here, 2i times 8i. So 16i squared. 16 times -1. So -16 is the answer. Okay, here we go on number 7. What do we want to do on these? Well, the first thing we want to do is fractionalize those. Okay. Now, we find there are 2 ways. You remember there were 2 ways on these kind of problems. There was the easy way and the hard way. I'm not going to mess with the hard way. Just going to show you the easy way. Okay. Find the common denominator of all 4 denominators, which in this case is 1x, right? Okay, so my least common denominator is x. So then what I'm going to do is I'm going to multiply every term by x. Oh, I don't want to mark up there. I better rewrite this. 2 times x over 1 minus 3 times x over x, 4 times x over 1 plus 7 times x over x. Now we cancel wherever we can. Nothing to cancel here. That goes 1 time and 1 time. That goes 1 time and 1 time, and nothing to cancel there. Look what we got for denominators. Everything is 1s. So therefore, this problem becomes 2x minus 3, because that one's a 1 now, over 4x plus 7. Now, if either one of these would factor into something that would cancel, you should, but they don't. So, answer. And by the way, on the final, it will be a great help to the grader if you will box your final answer. Okay, don't circle it, box it. You can circle for subparts, box for the final. Actually, I've modeled that for you a few times. Okay, here's another one. This is multiplication. So that makes this one easy. If it was an add or subtract, it'd be a whole lot harder. Basically, what is the rule for multiplication? Cancel anything you can. What is the rule for add and subtract? You got to deal with the common denominator thing. Okay, so in this case, I'm going to factor these. This becomes y minus 1, or excuse me, 4, y plus 4. This becomes 3 times y plus 4 times y plus 4 over y minus 4. Okay, now we got some stuff we can cancel. This one will cancel either this one or that one or the other. Doesn't matter which one you use. This one will cancel that one. Okay. What?
Would be the 3y plus 4 not cancel with the top one as well? 1 for 1.
No, you cannot. You cannot do this. You have to use whole parts. Okay.
Off the numerator.
Cancel out both of them.
Well, I said I could cancel this one and that one, or this one and this one. If you like it better.
No, he was asking if you could cancel both of them or just the bottom.
No,
Or just the one on the denominator.
no, you cannot. I used up all of this one, killing off that one. Okay. Now, if this had been a square out here, then the answer would have been yes. If this had been a square right here. Yeah. Okay, well, I've got everything that'll cancel. So what have I got left? I got y plus 4 in the numerator over 3 in the denominator. That's good enough. I suppose if you wanted to, you could change it to 1/3 y plus 4/3 if you wanted to, but there's no advantage. It won't be wrong, but it's up to you whether you do or don't. Okay. For those of you who can't read this, it says factor 6x squared plus 7x plus 2 is what that says. Okay, well, this one's not a particularly pretty one. You can't take anything out of everything, which is always your first option. So you got choices of 1 times 6, 2 times 3 are your possibilities on this 6. Okay, your possibilities on this 2 are just simply 1 times 2. So 1, 2. I look at my rule of signs and I'm going to add. Now, I want to end up with a 7. If I use the 3 here and the 2 there, I get 6 here and I would get 2 here, which is 8. Will work. So obviously that isn't the right combination. But what if I put the 2 here and the 3 there? 2 times 2 is 4. 1 times 3 is 3. 4 plus 3 is 7. Ding. Matches. So then my answer is and in both cases they're pluses. So your answer is 2x plus 1 times 3x plus 2. Box. Hopefully this is refreshing some memories. Oh, remember when we were having a good time? No. Okay, write a quadratic equation having solutions with 3 and -2 in standard form. That means they want us to write an ax squared plus bx plus c equation. Okay? Now, they give us some hints. They tell us x equals 3 and x equals -2. This generates x minus 3. This generates x plus 2. Why? Because x minus 3 equals 0, plus 3 plus 3, x equals 3. That's just how you switch back and forth. Okay. Now, I've got these two, and they are multiplied together. These are the factors of that equation that we got to discover. So now we just simply multiply. X times x is x squared. X times 2 is 2x. 3 times x is -3x. -3 times 2 is -6. X squared minus x minus 6. Done. Okay, any questions about this one? This one kind of came in the back door, didn't it? We did it backwards from the way we did the other one. Actually, there should be an equals 0 and equals 0 on these, because it is an equation. So there should have been an equals 0 on it. Let's see if I can expand this. Not quite. Okay. This is a problem that consistently gives students trouble on the finding. Okay. And it's actually one of the easiest problems on the test. Well, the problem is they don't follow the directions. It wants you to factor out a single common term that'll go with these, but you've got to leave it times the leftovers. And people don't leave the leftovers. Okay? Leftovers. I'll explain myself in a moment. Okay, we start looking at this. Let's look at the numbers. 24, 6, and 12. Is there any number that'll go into all three of those? 6. So if I take 6 out of each one of those, I got a 4, I got a 1, and I got a 2. Now let's go to the A's. A cubed, A squared. I can take out an A squared. Okay? I'm going to take out all of that A squared times this one. I'm just going to take 2 of the 3 of these. So this is now A to the first. Let me do it this way. A to the first. Okay? And likewise, if I take an A squared out of this one, I leave an A to the first. This A to the first and that A to the first are what I'm referring to partially as leftovers. Now, the B's. Looks like a single B is all I can take out of there. Now, do you know what the question is? Is it a bubbly bee? Okay.
That went over like a lead balloon.
This goes one whole time. This leaves me B to the first. This one leaves me B to the second. Okay? So what do I end up with my answer that they want on this thing? My answer that they want on this thing is this times 4A minus AB plus 2B squared that. And a lot of students leave my leftovers off. Okay? You don't look certain. Tom?
Oh, me, sorry, no, I'm just really concentrating on that.
Yeah, that's fine. Yes.
Would you still also leave the leftovers if it said find the greatest common factor? Or is it only because it says factor out?
It said factor out. If it said find, chances are that's all you're gonna need. I'm just, that's fine.
Taking really,
No, I was just making sure you were okay.
oh, yeah.
Yeah. I can't help but keep noticing that hat of yours with the fuzzy on top. I like that.
Oh.
It keeps grabbing my attention. Okay, solve this equation. Okay. Well, 4 to the second equals 8x. What have I done? I have changed it to exponential. Okay. Now, based on that, 4 to the second is 16 equals 8x. Divide both sides by 8. And you get x equals 2. Okay. Box. Let's see if that works. If that's a 2, I got a 16 in here, right? 4 to 16 is the second power, so it checks. I'm the only one that gets to sing.
Sorry. Song second.
And that's only if I'm trying to punish you. I don't think you guys have heard me sing. Or if you have, my pity's upon you. This one I ought to be able to Expand a little. There we go. Solve the equation or inequality. Okay. How do I get rid of this radical? Square both sides. Okay. So I'm going to square this. I can't draw on that because it'll ruin it. And I square this. Okay. When I square this, when I square a square root, I get what's called the radicand. And over here I get 36. Take the 8 over. 7x equals 16 minus 8 is 28. Divide both sides by 7. Where did I get that? I almost said divide both sides by 4. Where did that come from? So instead of 28 is 4 times. Easy to make mistakes like that. So I get 1x equals 4. What's the biggest mistake that I told you on the test review that people make on this problem? They forget to do the plus or minus. They forget to do the plus or minus on absolute values. When we get rid of the absolute value, then we have to make this plus or minus 8. Well, that generates 2 problems. 3x plus 7 equals positive 8, and 3x plus 7 equals negative 8. Okay, and people forget to do that negative side. Even if they put this here, sometimes they forget to do this instead. Okay, well here, minus 7, 3x equals 1. Divide by 3, divide by 3, x equals 1/3. By the way, notice the difference in what I did here. I am dividing both sides, so I use the slash. As my answer, I used a flat fraction bar, which I expect you guys to do, and so will your algebra team, college algebra teacher, whomever it might be. Well, we're not done yet. We've got to do this side. Minus 7, 3x equals negative 15. Divide by 3, divide by 3. X equals negative 5. We got to check these. Anytime it's absolute value, anytime it's square root, we got to check it. We actually didn't check this one. We'll forward work on this. 28 plus 6. Yeah, that's a legitimate square root. You didn't get a negative square root is what you're checking for. Okay, over here, if we put the negative in here, we get negative 15 plus 7, that's negative 8. Well, is negative 8 equal to negative 8? Absolute value of negative 8 equal to 8? Yeah, we're good. And this one, absolutely good. Okay. So, we're good either way. Now, let me ask you, before we go any farther, stop your writing momentarily. Have any of these problems been scary so far? Not really. Maybe a couple of them looked a little spooky until you really figured out what you were doing. But these are problems just like you're going to have on the final. Okay? These are lookalikes. So I want you to go in there with confidence, okay? All right, let's look at this one. This one's just the opposite of the one we had before. We're going to square root both sides this time, but there's the problem. So I'm going to take the square root here, and I'm going to take the square root there, but I've got to do the plus or minus. When you take absolute value away, you got to do that plus or minus. When you take a square away, you got to do plus or minus. You notice we didn't do plus or minus over here when we squared both sides. Okay, this side just gives me 2y minus 4. That's the easy side. Well, here we're going to get plus or minus 8, right? So now we got to break it into our two parts. 2y minus 4 equals positive 8. 2y minus 4 equals negative 8. And I really would suggest that you write down both of these before you start solving either one of them. Because if you just write this one down first, solve it, you might forget about that one. Plus 4 plus 4. 2y equals 12. Divide by 2. Y equals 6. Okay. This one, plus 4 plus 4. 2y equals negative 4. Divide by 2. Divide by 2. Y equals negative 2. Okay. Questions on this one? What? Not really, because it didn't start off as square root. I mean, you can always check it. I mean, that's a good idea if you have time. Okay, now.
Just hope for it.
Say what?
You don't have time to just hope for it.
Yeah.
Open pray.
What's the hope?
Punt and hope you gain some yards on the return. Okay, so this one. How do I get rid of this x in the denominator? Multiply both sides, right? But anytime we've got a variable in the denominator, what have we also got to do? Do a domain check. Do a domain check. See what numbers it can't be. Well, x can't be 0. We don't need to do any calculation to figure that out. So we write up this disclaimer, x is not 0. Now let's work it. What if this were x minus 1 down here? Well, then we'd have to do x minus 1 equals 0, plus 1 plus 1, x equals 1, not. You know, if it were that, but it's not in this case. So we're going to take an x times that and an x times that. These two x's will cancel, leaving me 2x plus 12 equals 5x. Okay, let's get the x's on one side and the numbers on the other. Is faster in this case to take the numbers over here, I mean, the x's over here. So minus 2x minus 2x. 12 equals 3x. Divide by 3. And x equals 4R X equals 4. And since we didn't get 0 for an answer, we're okay. Oh, we're halfway through. We're halfway through. Except I heard a rumor today there might only be 30 questions instead of 32. Apparently in the original copy, there were 2 almost duplicate problems. You know, working exactly the same way and got the same kind of answer. So, yeah, on a draft copy of it.
Oh, I was thinking something where it was like 64.
No, I told you from the beginning, there's 32 questions. Okay, I'm gonna rewrite this big enough you can see it hopefully. X plus 3 external minus 3 equals X. Okay. What have I got to do? Isolate the radical. So take this over to the other side. Plus 3 plus 3. And I get radical X plus 3 equals X plus 3. And I'm going to put a parentheses around that. And there's a reason I'm going to put a parentheses around that right now, because I'm going to square this and I'm going to square that to get rid of that radical. Okay. And I'm not just squaring the X and just the 3, I've got to actually multiply that thing out. Now, on this side, it's easy. That side, I get X squared plus 6X plus 9. Now, does anyone need me to show how I got that?
Yeah.
Or first term squared plus 2 times the first term times the last term plus the last term squared, or in other words, X squared plus 6X plus 9. 2 different ways of working that one. Okay. Whichever way works for you. I'm going to erase this, or at least that for sure, because I need to have this in a moment. Well, actually, I'm going to need space here too. Okay, so now I'm going to take this over there and that over there. So I've got 0 equals X squared minus X minus 3 minus X minus 3. That's a 9. Okay, and I didn't put my, I put a reverse curly Q on that one. Plus 5X plus 6 is what this thing simplifies to. Now I gotta factor that thing. Is it? Yeah, as a matter of fact. 0 equals x plus 3, x plus 2. So x equals -3, x equals -2. We do have to check this. We do have to check this. Let's try the -3 first. -3 plus 3 radical minus 3 equals -3. Okay, I've replaced x with -3. This gives me 0, which is just 0. So -3 equals -3. It checks. Now let's check the other one. -2. So -2 plus 3 radical minus 3 equals -2. This gives me square root of 1 minus 3 equals -2. 1 minus 3 equals -2. -2 equals -2. It checks. Okay. Now we got another absolute value, only this time it's right, not equals, greater than, greater than. I'm gonna rewrite it. Okay. Well, I get rid of this. Greater than, now watch this, +4 and 3x minus 2 less than -4. On the negative side, flip the symbol. On the negative side, on any absolute value, where you have to do a plus or minus.
So if the original equation,
Say again,
if the original equation had a negative order, instead of zero, then we still put it. Negative order and positive order. So that was something else.
you're saying, what if this were a -4 in the beginning? If this were an equal and that were a negative, then it would be an untruth. No solution. But because this is saying it's bigger than -4, starting with 0, there are numbers that could be true. So you got to be a little careful on absolute values. But what you were remembering is if that were an equal and a -4, you can't get a negative absolute value, because it's always the positive. Okay, let's finish these. +2, +2, 3x greater than 6, divide by 3, x greater than 2. Okay, over here, +2, +2. Okay, so 3x less than -2. Divide by 3, divide by 3. X less than -2/3. So I'm going to circle those. Okay, now they want us to graph this one. I'm going to arbitrarily call that 0. Okay, so here is 2. And right here is -2/3. Now then, let's see what these things are saying. X is bigger than 2. So it's everything this way. Use a parentheses because there's no equals. Okay. This one, it says X is less than this. So it's everything this way. Now there's the graph. Yes. Don't. We're gonna play grown up now. You're gonna have to use these in college algebra. You may as well get used to it. Okay, don't use dots and circles. Okay,
On the line graph.
on a line graph. Actually, if you've got a missing point on a two-dimensional graph, you still use an open dot. Now, one more step left. It doesn't say it, but it's implied. When this says solve, that expects an answer either in interval or set notation. And the preferred is always interval, especially if you got to graph it. Because here we got negative infinity to negative 2/3, parentheses, union in this gap to positive infinity. See, interval notation is really easy from the graph. Because if you got a gap, that's where the union symbol goes. If you got two gaps, then there are two unions. Okay, question on that one. Now, on my test, I always put either interval or set, but on the final, they may or may not specify to solve, has to be in one of those forms. Interval is always the preferred. Can you read that? Yeah. Okay. Use the quadratic formula. We didn't do completing the square. So that won't be on the test. Completing the square won't. So in this case, the instructions would only be use the quadratic formula. Okay. Now I did give you that one handout. This one, where I showed you completing the square, but I don't expect you to know it. Okay, so in this case, what is the quadratic formula? I would like to see you write down this. Negative b plus or minus square root of b squared minus 4ac all over 2a. I would like to see you write that formula first, and it's going to be worth 1 point by itself. Then what I would like to see is I would like to see you put in your substitutions. Okay, negative, whatever b is, 4 plus or minus square root of 4 squared minus 4 times a times c. A is 1. C in this case is -5. All over 2 times A, which is 1. You get that much and you're gonna get 2 out of 4 points. Okay? Biggest problem that people made on the last test was they left off this square right here. All right, now let's work this thing out. Equals -4 plus or minus square root of 16 plus 20 all over 2 equals -4 plus or minus square root of 36 all over 2 equals -4 plus or minus 6 all over 2. And now this breaks out into the 2 problems. And that, by the way, that's a 6, not a B. Okay? So for the plus side, I've got -4 plus 6 over 2, which is equal to 2 over 2, which is equal to 1. So one of my answers is x equals 1. For the minus side, we've got -4 minus 6 over 2, which is -10 over 2, which is -5. So we also have x equals -5. Now, as soon as you finish copying this down, I've got a little aside comment to make to you. Sorry. What if? What if? What if I gave you an equation, maybe like that one that had a 6 on the front of it earlier, that for the life of you, you could not figure out how to factor it, and the instructions were factored? Do this, then take these 2 answers and backstage them to factors. That's your fail safe. Okay? You see what I did there?
No, I know, yeah,
Oh, okay.
I'm sorry, I'm working.
You know, that's if you got an equation that you're supposed to factor in this for the life of you, you can't. You can get it by back factoring it after you get the answers. Okay. All right, systems of equations. Now, remember we did them 2 ways. We did them by the substitution method, and we did them by the elimination addition method. Okay? Unless they tell you, and they probably won't, work whichever one feels easiest to you. Okay? I'm going to work this problem both ways. When we do it by the elimination method, or sometimes called the addition method, what is the first thing we do? We get an opposite pair. Okay, do I have an opposite pair? No, but almost. So if I take this one by 2, and that's the way you can show it, then I've got 6x minus 10y equals 4. And the second equation is 3x plus 10y equals 5. Those two go away, leaving me 9x equals, in this case, 9x equals 1. What? Okay. That means that that's the x value of my ordered pair where the lines intersect. Notice I put this up here now so I don't forget it later. Now then I need to find the y value. Which one of those equations looks easiest to you?
Top one. Sure, fine.
Really? I would have chosen the bottom one because it's a plus. Here I gotta divide by a negative. That's just more opportunities for mistakes. So I've got 3 times 1 plus 10y. Besides, dividing by 10 is real easy. Equals 5. 3 plus 10y equals 5. Actually, you don't have to show this as 2 separate steps. Minus 3, 10y equals 2. Divide by 10. Y equals 2 tenths equals 1/5. Circle. Box.
Same with the opposite way, but maybe.
You still get the same answer. Now, you want me to work this one by substitution also? Yes? Okay. This will be the last problem we'll work tonight. We'll take up on Tuesday with problem 21. This one is not going to be particularly pretty. I think, wow, this is going to be particularly ugly no matter how I do it. I would never work this one by substitution. Look what happens if you try to isolate this x. You get 3x equals 5y plus 2. Divide everything by 3. X equals 5/3 y plus 2/3. That's an ugly substitution value. I mean, you can do it, then substitute that into this one. Okay, right here. Well, what if you tried to use y as your substitution value? Negative 5y equals negative 3x plus 2. Divide by negative 5, divide by negative 5, divide by negative 5. Y equals positive 3/5 x minus 2/5. That way to substitute into this. That's no better. And I could do the same thing with these two, and it would still be no better. So I would never do this one by substitution. Okay? All right, for that, I'll start on 21. Remind me to, Tuesday night, no class Monday. No class Monday. Get all your Alex caught up, get all of your tests done, so you come in here at 100%. Okay, so. You too. See ya. Go rest in peace. What?